So let's compare free energy, standard free energy, the voltage, standard voltage, and equilibrium constant. All of these quantities measure spontaneity, so it makes sense that they should all be related somehow. So remember, if delta G is negative, or if E cell, the voltage of the cell, is positive, or if KEQ, the equilibrium constant, is greater than 1, these are all different ways of saying that a reaction is spontaneous. So since they all measure spontaneity, they're all going to be related to each other. So we'll look at a couple of equations where we can see how they're related. The first thing we'll compare is the standard free energy with the standard voltage. I'm not going to derive this equation for you because you need some calculus and it's not worth it. Instead, let's just remember that this is your standard free energy. Okay, so remember this is good at 25 degrees Celsius. And all of your concentrations have to be 1 molar, and all your gases have to be 1 atmosphere. This is your standard voltage. Okay. N is the number of moles of electrons. So what you have to do is you have to write your two half reactions and balance the electrons and see how many electrons are being transferred, how many are being produced in the oxidation and then used up in the reduction. I'll show you how to do that. It's not too hard. F is called Faraday's constant. Okay, it's just a constant. I'll give it to you. You don't have to memorize it. Okay, named after a guy named Faraday. And it is 9.648 times 10 to the 4th joules per mole per volt. Okay, so again, you don't have to memorize that. We'll show you how to use it. And then let's look and see how the voltage is related to the equilibrium constant. So remember, we learned before how delta G was related to K. So we did that, I think, last chapter. And now we just learned that delta G, standard free energy, is minus NFE. So if they're both equal to delta G, then we can set them equal to each other. So we'll say RT ln of K equals NFE. Okay, and then if you rearrange all of that, you get that's a standard right there, that E0 is RT over NF times the ln of K. And if you're not at 25 degrees Celsius, you use the equation like this. Since we're usually at 25 degrees Celsius, what we're going to do is we're going to take these three numbers, which are all constant, right? R is the gas law constant, T is 25 degrees Celsius or 298 Kelvin, and R is a constant, and we're going to give it a number. Okay, it's 0.0257. So you'll often see this equation written as E0 equals 0.0257 over N times the ln of K. Okay, and that's true at 25 degrees Celsius, which will be most of the time, but not all of the time. Okay, so this is often how you'll use this equation. So why don't we try a problem where we try these two equations. So for this reaction, 3 silvers plus a nitrate plus 4H plus gives you 3 silver ions and NO gas and 2 waters. Let's see if we can find the standard free energy change and the equilibrium constant. So the first thing we're going to do is write the half reactions and find the standard voltage from that table of reduction potentials. Okay, so you've got 3 silvers, gives you 3 silver ions, and to balance that you would need 3 electrons. Okay, so that's this part of the equation right there. And then we're going to write this part of the equation as our second half reaction, NO3 minus plus 4H plus some electrons. We'll figure that in a second. Gives me NO plus 2H2O. Okay, and if you look, you'll see that you need 3 electrons here. Okay, so the charge on the left is 0 and the charge on the right is 0. The reason it's important to do that, for one reason, is this right here. That tells us that the N in that equation is 3. It tells us a number of electrons being produced and then used up. Okay, so the voltage for this one here from the table is negative 0.799 volts. And for this half reaction, it's 0.964 volts. So the total is going to be 0.165 volts. Okay, so there's your standard voltage for that reaction. So what we'll do is we'll take that now and see if we can calculate delta G. Okay, so standard delta G is minus NFE, E0. So we're just going to plug in our numbers. So minus, now N we just discovered was 3. Faraday's constant is 9.648 times 10 to the 4th. And we put in our standard potential, which we just found. And you're going to get negative 47758 joules, or a more sensible answer, minus 47.8 kilojoules. Okay? The negative says it's spontaneous. This said it was spontaneous because it was positive. And let's go ahead now and use that and see if we can find the equilibrium constant also. E0 is 0.0257. Okay, we're at 25 degrees Celsius here, over N times the ln of K. So the ln of K is N E0 over 0.0257. Okay, we figured out N was 3. We figured out that voltage was 0.165 divided by 0.0257. So the ln of K is going to be 19.3. So we take the inverse ln of these things, and you get 2.3 times 10 to the positive 8. Again, a big number says it's spontaneous. Okay, so it's pretty easy to relate all of these things at standard conditions. That's really all there is to it.